Okay, now we can talk about rotational kinetic energy and moment of inertia, which is section 10.5. Okay, we know that linear kinetic energy, which is K equal to half mv squared. But in rotational motion, okay, V is equal to R multiplied by omega. M is the mass, it's the same. So when we put R omega in place of V, it will be R squared omega squared. Okay, so we can combine them as this. K is equal to half M R squared multiplied by omega squared. We need them to be in as the ordinary view, which is V omega. M R squared, we will talk about this quantity. Let us look now about for this example. If we have a ball, it is not rotated, okay? It is just a ball sliding on the surface. We have no frictions. Or a box, just a box. They are in the same mass and the same velocity, okay? They have the same kinetic energy. If they have mass equal to 2 kilograms and velocity equal to 5 meters per second, okay? Now, how much that kinetic energy? It will be half multiplied by m, which is 2, v squared, which is 5 squared, which is 25. Then the kinetic energy will be equal to 25 joules for the box, sliding box or sliding ball. There is no change in its orientation, okay? Look at this ball. It is rotated, but in its place, its velocity, its horizontal velocity is 0. It has just rotational velocity or omega or angular velocity. It is just rotated in its place like this. It is not going like this. There is no linear motion. It is just in its place, okay? Now we need to calculate the kinetic energy, but the rotational KR, rotational kinetic energy, which is equal to half, as we see here, m r squared omega squared. Now we need to know the radius. In the first state here for linear kinetic energy, we don't need the radius. Even if it is our body is a ball or a wheel, we don't need to know the radius because we don't have any radius in our equations here. But here for kinetic energy in rotational motion, we need to know that radius. So we have the radius. Also we need to know the omega. If we have the radius is 5 centimeters, which is 0.05 meters, and velocity, the linear velocity is 0. The rotational velocity is 5 radians per second. Okay? Now, the rotational kinetic energy is equal to half multiplied by m by r squared by omega squared. Put the numerical values. The mass is the same mass, 2 kilograms. Then the rotational kinetic energy will be equal to 0.0625 joules. It is not the same as this one. We have omega 5 radians. We have the velocity 5 meters per second. We have the radius is 5 centimeters. 5 centimeters, it is just like this one. Okay? And we have different kinetic energy. Let us now look again at our formulas. For linear kinetic energy, we have K is equal to half m multiplied by v squared. Half is a half. M is the mass or the inertia. Okay, it is an ordinary mass. The v is the linear velocity. It is easy to be understood. Okay, now look at the rotational kinetic energy. We have the rotational kinetic energy. We can put it K just without R, but R to be known, that is rotational kinetic energy, which is equal to half, it is the same half, multiplied by mr multiplied by omega squared, mr squared. Look at mr squared, it is mass multiplied by r squared. This is in physics, has a name, which is moment of inertia. It plays a role just like an effective mass and rotational motion. You will find this using the or various examples. You will see that this mass quantity different than this one. Okay, the angular velocity, it is the angular velocity. We know that omega is equal to v over r. Okay, so mr squared in general, we can call it moment of inertia, which is the effective mass in rotational motion. Okay, now I, which is the moment of inertia, okay, in general is equal to mr squared, and that depends on the shape of that body. We will see that in the next video. But now look at the kinetic energy in rotational motion. What is the final form for it? It is half I omega squared. I is the effective mass. So now this formula, it is like that, this one in linear motion, but we don't have ordinary mass, we have I. We don't have linear velocity, we have angular velocity. Now, for example, if I is equal to 10 kilograms meter squared, this is the units for it, because it is mass multiplied by length squared. And omega is 3 radians per second. It's simply, we can solve and find the rotational kinetic energy, which is equal to half multiplied by 10 multiplied by 9, which is 45 joules. Next, we will look more careful about this quantity I. Thank you.